intern at a San Francisco startup, and I was rapidly promoted to being the release engineer. And so, how many people have had a release engineering process that looks something like this? I would check out the latest version from CVS, I would copy it to the servers, and then I would install it and restart the server. When I was done with that, I would do that on the next server until all 15 servers had the latest version of the website. Then a few weeks later, or a few months later, we hired a real software engineer, and he taught me Bash. So my release engineering software process looked something like this, except for then I had to write a little command line Bash script to make it do that. And that was how I was running one of the world's largest e-commerce sites for a while. So fast forward many years, and I got a job at a different tech startup, and this guy was my boss. Nate Campy, who wrote this book, was my boss, and he was like, we're going to do CF Engine. We're going to make everything run using configuration management. And it was a revelation, the fact that there was this huge tool set that would do all these things for me, and I no longer had to, write my own Bash scripts. I mean, that Bash script that was on the previous page eventually turned into like a multi-thousand line Perl script that had a web UI and everything to do release and management at this company. And as far as I've heard, it's actually still running release management at that company. But I worked here, and we got most of our infrastructure converted to CF Engine. In fact, we went from it taking a day to provision a server to taking an hour to provision a server. We went from having the probability of something going wrong when deploying a server be like 50-50 or 99% chance that it would be correct. We went to, we understood 70% of the servers, like, what does that server do, and how do you build a new one if it dies, to we could rebuild every server in the entire infrastructure in an hour. So that was awesome, and it was really such an amazing and different way to do operations. I left that company and went to another tech company, and I was interviewing with them, and I was like, are you guys using configuration management tools? They're like, well, a little bit. I mean, some. Not everything's really automated yet, but we're working on it. And I got to the next interviewer in that same round of interviews, and I'm like, what are you guys using? And they're like, we're using Chef. I'm like, wait a second, the guy before you said you're using Puppet. Which one is it? He's like, well, we're using Chef. Okay. So I took that job, and true story, they were using both. But we got rid of the Chef installation, got everything to Puppet. We used Puppet for a long time, and we scaled to 20 data centers, thousands of servers, and we ran all of our production infrastructure on Puppet. So let me back up for a second. I'm Jonah Horrowitz. I'm on the Netflix Cloud Operations Reliability Engineering team. I've been doing Sys Admin work since I started at BBS with my friends that had dial-up lines. I was running DOS and DeskView. Anyone ever run DeskView in this whole place? It's like one person. Yes, 3, 4. Okay. So I've worked for a lot of different tech companies, large and small. I was at Walmart.com, Quadcast. I'm a little startup I launched with my friends. The Netflix Cloud Operations Reliability Engineering team is, I think if you were at Dave's talk earlier, we're the last line of defense at Netflix. So while we expect every microservice team to run their own operations, there ultimately has to be a team that, when nobody knows what's wrong, does the initial triaging steps to figure out what's wrong. We do a lot of other things, but one of the big things we do is incident response. So this past Saturday, we were all sitting on our laptops managing one of our largest outages in a while and getting backed up a little bit by our PR team tweeting out cool stuff about us. When there is an incident in Netflix, we manage the incident. So we're not necessarily troubleshooting once we've figured out which teams are most likely responsible. We've got their teams and their engineers who know how to fix things involved, and we're making sure that the communication flow is good, that the PR team knows what's going on so they can tweet cool things, and so that, and making sure that everything's captured so we can do review and follow up after the incident's over. So, to the topic of my talk, what sucks about configuration management? And disclaimer, hey, I'm sure all of the configuration management companies have answers to some of my complaints, and most of what I don't like can be worked around through some combination of best practices, newer versions of the software than the ones I used to use, and other things. But I think my point still stands. Regardless of how good you can make configuration management, all of these things will always suck. Scalability, in two different dimensions. One, it's actually just hard to get your configuration management tools to run when you're at a couple thousand servers. Like Puppet Master or the other companies, they don't do a good job at managing thousands of nodes in your infrastructure. And then scalability across your organization. If you have to give commit access to your Puppet repository to everyone in the company, and then you have to teach everyone the Puppet domain-specific language for Puppet, and that's just so that they can manage their servers. Or you do the other thing, you have a small ops team that is responsible for managing the Puppet code that runs on your servers, and you don't give anyone else access to it, and then you're not doing DevOps at all. So the last thing is that it's slow. Like if you launch a new server with Anaconda, and then it installs Puppet, and then it downloads your Puppet configs, and it runs your Puppet repo, okay, so like 3 hours later, you have a working server. And that doesn't solve the first problem that we had, which with my Perl script, which is that release engineering still sucks. How are you going to get your code into production separate from how you get your servers up and running? And how do you make sure that you're running the right version of your software? And how do you do releases? Do you release to all your servers at the same time, or do you use some crazy flags to set like this is the pre-release group and this is the regular group? And how do you keep those two from diverging? And how do you make sure that someone doesn't set the wrong flag on the wrong server? So what's the alternative? At Netflix, we use what has been known to be called immutable infrastructure. We release something once, and then when we're done with that server, we throw it away. Now, Amazon gives us a lot of help in this. Running a virtualized environment, we use what are called Amazon AMIs, which are Amazon Machine Images. It's essentially a VM image. We start when a software developer makes a commit. We use a tool called Nebula. The code is built into a Debian package. Then it's run through its testing procedures. Then we have a base AMI that's built by our performance engineering team. The package, the software package is installed on the AMI, just like as if you typed apt-get install package onto the AMI, and then that AMI is frozen. So that AMI, the frozen AMI, is uploaded to Amazon, and then we take, let's say there's a deployment pipeline with some canary stages, some testing stages, but ultimately we do a red-black deployment, which means we spin up, you have 100 servers in your current production cluster, we'll spin up 100 servers next to it. Once your servers are safe and healthy and running properly, we'll cut over your traffic to your new servers. If there's any problems, we can cut back to your old servers. One thing we're not doing, though, is running a Puppet job to update the code on your existing servers. Your existing servers are installed once, run for as long as they're needed, and then killed. And when there's one change that needs to be made to that server, we bake a new image, we push out the new image, and we run it with the new code. So we don't need to use any configuration management. It also means that we're able to scale our clusters very quickly and very effectively. It doesn't take 3 hours to launch a new instance, it takes 5 minutes to launch a new instance. In fact, one of the things that we're best known for is chaos engineering, and you can't have Chaos Monkey running in your production systems if it takes you 3 hours to launch an instance, or if an instance upon launch is not already configured correctly. So every tool that we use is based upon the idea that our infrastructure is small, as Corey Quinn hates me to point out. Our entire infrastructure is based around small microservices that are stateless, and that gives us the power to run this infrastructure. And if we couldn't start instances in a few minutes, we wouldn't be able to do it either. So a lot of what we do is dependent upon Amazon or using a cloud provider of one sort or another, but it doesn't necessarily have to be. Docker is essentially the same thing. You can bake a Docker image. In fact, you can bake a Docker image even faster than you can bake an Amazon image. And you launch it, and if you're running configuration management inside your Docker containers, you are completely doing it wrong. So, bake your Docker image, push it to production. When you have a new version, you push that out as a new Docker image, and you will be happy. So here's some bio info about me. The tool that is like the master plan for everything we do, Spinnaker, my favorite Netflix open source tool, is on Netflix GitHub IO, along with 70 or plus other services. And we're, of course, always hiring. Finally, these stickers. So if you have like a puppet or a chef sticker on your laptop and you'd like to cover it up with a little circle slash, you can come. You can come to get this sticker from me afterwards. I think I have a few minutes left for questions. We actually only run that second red-black cluster instance for maybe an hour or two. So while there is some on-demand usage of Amazon resources with all the different teams pushing at any given time, the old instances don't stay around that long. Because we can, like I said, launch them in 5 minutes. If we need to scale up a cluster of an older version, we can do that.
How badly did Chaos Monkey go the first time you guys let it loose?
So I wasn't there, but I will tell you this. When we first rolled out Chaos Monkey, it was a very slow and deliberate process. We allowed teams to decide whether or not their infrastructure or their software was ready to run with Chaos, and we let them each opt in to being part of Chaos. That worked for a little while, but of course there were stragglers, so we flipped the model, and we said, now it's opt out. You have to justify why you can't, you the only team at Netflix that can't run Chaos, why your team can't run Chaos. And that upped adoption to the point where almost every service, basically every service in production, anything in the customer serving infrastructure is being controlled by Chaos right now. And now we fail entire regions. So, the truth is if you're not running properly, and we shut down everything in US East so that we can fail the US West, your system better keep working.
You build AMIs pre-testing and then use the same AMI for production, or do you?
Yeah, so that's definitely part of it. We start with when the developer checks in their code, and it kicks off generally like a Jenkins job that will build their software, launch the build process to build an AMI, the bakery. It's all also open sourced. That AMI is the same AMI that is carried all the way through to production. So there's no difference between what's tested and what's in production. It's always the same. And we use Docker too, actually, now for some of our services so that we can do sort of shorter, faster cycles.
So the follow-up on that then is, how much stuff do you guys inject via user data or Docker environment variables or that sort of thing to deal with differences in pre-production versus production?
So we have several environments based on like Amazon accounts. So if you're in the test account, you'll be talking to the test metadata service, and you'll be pulling your, there'll be local environment variables that say that you're running on a test instance. So if you have something different about who you talk to, like you're probably going to, we have a service called Eureka Discovery that allows you to find other services. Most of the services talk to each other. So if you talk to the discovery service in the test environment, you're going to get test other clusters back. You talk to the discovery service in the prod environment, you're going to automatically be talking to other production clusters. Looks okay, good. Come find me at the Netflix booth. I have plenty of stickers.